Hey guys, welcome again to another video, and today we are going to be talking about how to calculate empirical and molecular formulas. Well, what even are imperial and molecular formulas in the first place? Well, an empirical formula is the lowest whole number ratio of the atoms of an element in a compound. For example, like C2H2, that's the slowest and simplest ratio of atoms for ethene. But on the other hand, molecular formulas are the actual numbers of atoms in a molecule of a formula. For example, naturally, there is a compound like C2H6. This is what is occurred in nature. You find C2H6 in nature. But this is not the simplest form of whole numbers. You can simplify this to CH3, right? This would be the empirical formula, but C2H6 is what's found in nature, and that is its molecular formula. Now, how do we even calculate empirical molecular formulas? Well, first, let's talk about empirical formulas. The steps on how to calculate empirical formulas are honestly pretty simple. Step one is to find the mass or percent composition of each of the elements in the formula. And it could be either or. You could be given either or, and I'll show you exactly what to do with those in a second when we do practice. Step two, you find the number of moles of each element, and there's like multiple ways to do this if you have a percent or the mass, and it's to find the moles of each element, which is a process I'll tell you guys later. And step three, you have to divide the moles by the smallest number amongst the mole numbers to find the subscripts. These subscripts are just like how in C2H2 there's 2 carbons and 2 hydrogens. Those are called subscripts. And then you can just multiply by whole numbers because your subscripts might be like decimals, etc., etc. Let's just practice so you get an idea. This is our first question. The question says, a compound has a mass composition of 52.2% carbon, 13.1% hydrogen, and 34.7% oxygen. Find the empirical formula. Well, how do we do that? I'm going to refer back to my steps. First thing first was to find the mass or percent composition of each element. This was already given, that it's 52.2% carbon, 13.1% hydrogen, and it says here 34.7% oxygen. Now, step two, I'm going to refer back, is to find the number of moles of each element. Well, wait, so how do I do that? Well, there's a certain step. The question here does not specify the compound or if there's a substance with a certain grams. So for everyone's ease and everyone's everything, let's assume that there is 100 grams of said compound, of said substance, okay? And the reason why this is helpful is because if there is 100 grams of a substance of this compound, that means if it's 52.2% carbon, that means that there is exactly 52.2 grams in that 100 grams, because 52.2% of 100 is just 52.2. Simple math. So if you assume that there's 100 grams, then the same math goes for this 13.1% of hydrogen, meaning that there's 13.1 grams in 100 grams of said compound. We don't know what it is. We'll find out later. And then the same thing goes for the oxygen, how there's 34.7 grams of oxygen. So why is this even helpful in the first place? Well, it's helpful because to do step number 3, which says step number 2 is find the number of moles of each element. The way you find the number of moles is to use the atomic mass unit. And the atomic mass unit on the periodic table is always given per 1 gram, right? So it's like atomic mass unit, it's grams, and it's per 1 mole. So that's why it's so simple to do it, and that's why it's so helpful to do it in this way. So the next step that we will be doing is that we're going to find the atomic mass units of each of the elements. Carbon, I'm using my periodic table in front of me. Carbon is 12. Hydrogen is just 1. And then oxygen, I'm going to be using 16. And these are all grams per 1 mole, grams per 1 mole, and grams per 1 mole. Now, the next step is to find the number of moles. How do you do that? Well, you just divide the grams by its atomic mass unit. So 52.2 divided by 12, and I get approximately 4.35 moles. It's very important that this is in moles, by the way. And then let's do the same math for hydrogen. I'm going to do 13.1 divided by 1, which is just 13.1 moles. And then for 34.7, I'm going to divide this by 16, and you get approximately 2.17 moles. Okay, my step 2 is now complete. Now, it says divide the moles by the smallest number to find the subscript. Smallest number meaning out of these three numbers, divide each of them by the smallest number. And the smallest number here is obviously 2.17. Meaning I'm going to divide 2.17 by 2.17, 13.1 by 2.17, and 4.35 by 2.17. I'm going to get some numbers. This is just one. Okay, and then 13.1 divided by 2.17, you should be getting 6.0 approximately. And then for a 4.35 divided by 2.17 is just going to be approximately 2.0. And notice here that these numbers are very, very close to whole numbers, right? There's 2, 6, and 1, meaning that these are the subscripts, as seen in the thing, to find subscripts. And we've already found the subscripts, meaning that of carbon, there's 2, hydrogen, there's 6, and of oxygen, there's 1. Meaning our final empirical formula is C2H6O, 1 or just O. And that is your correct answer. Okay, guys, question number 2. Question number 2 says, a 400-gram sample of a compound is analyzed to contain the following: 192.0 grams of carbon, 25.6 grams of hydrogen, 166.4 grams of oxygen, and 16.0 grams of nitrogen. Determine the empirical formula. Okay, so let's start off, and feel free to do this question with me. Pause the video and do it yourself, and then come back if you want to see the answer, and let's solve this question ourselves. First things first was always, let's check our steps. Okay, find the mass or percent composition of each element. We've already done that. Okay, we know the mass. Now find the number of moles of each element. Okay, let's do that. So how are we going to find the moles? Well, let's start off with carbon, okay? So to find the number of moles, we have to get the mass, which is, for carbon, it's 192.0 grams, and divide it by the AMU. AMU of carbon is 12 grams per 1 mole, meaning that I'm going to do 192 divided by 12, and I'm going to get 16.00 moles. Okay, now let's do the same for all the other ones. Hydrogen is 25.6 grams divided by 1, and you should just get 25.6 moles. Same thing for oxygen is going to be 166.4 grams divided by its AMU, which is 16, and you should get 10.4 moles. And then nitrogen, which was given as 16.0 grams divided by 14, which is going to be approximately 1.14 moles. Okay, I have gotten all my mole values. Now what's my next step? Let's go check back. Now I'm going to divide the moles by the smallest number to find the subscript. Okay, out of these 4 numbers, the smallest one I see is the 1.14, meaning that I'm going to divide all of these numbers by 1.14. 16 by 1, divide by 1.14, which is going to just be approximately 14.04, and that's really close to 14, so I'm just going to say 14. Now I'm going to divide 25.6 divided by 1.14, since that was the smallest number, and that should be around 22.46, or just 22. And then for 10.4 moles, you divide that by 1.14, and you should get 9.12, or you can just round that down to 9. And then 1.14 divided by 1.14 is just 1, which means that it has a subscript of 1, meaning that the final empirical formula for this is C14H22O9N. Go to the next video for molecular formula.